Hey guys, so welcome to 4.4. We did some of this in class, okay? And so on starting with this video, we are going to do example 1. And let's see how far we can finish. So example 1, find the vertical, horizontal, and oblique asymptote if there is any. So the first one we're going to do is VA, okay? So vertical asymptote, you would need to write x equals if there is any. So we're going to start with that. Okay. Excuse me. So because vertical asymptote is really telling me that, hey, what is that x cannot be? So vertical asymptote is really related to the domain. So if you look at this, the domain of this asymptote, okay, I'm sorry, the domain of this function is that x can never ever be negative 3. Okay, that's the domain. So the vertical asymptote is simply x is at negative 3. Notice how they are completely related. Okay. The next part is you either have a horizontal or an oblique, but not both. Okay, and I would spell that out right here. Spell this out. I'm not going to write it out for you, but you should spell it out. You may only have an HA, which is horizontal asymptote, or oblique, but never both. Okay, so if you are listening, you should write it out so that way when you are studying, you are not going to make a mistake of finding both of them. Okay, so first we are going to go back and see when we would have an oblique. Okay, so let's go back to this definition right here. You have an oblique if your rational function is an improper. And an improper meaning that the degree on the top is higher than the degree on the bottom. So the first thing is I'm actually going to switch my pencil because just so I get something darker. I would rewrite this so that way it's in descending order. Okay, so rewrite r of x equals, on the top I don't really have a choice, I'm just going to rewrite 5x squared over. This right here is not in descending order, so I'm going to write it as an x plus 3. So this is a better version of that. Alright, so let's look at the degree on the top. Degree is, what's the degree on the numerator? Degree on the numerator is 2. Denominator, okay, denominator degree. What's the degree in the denominator? It would be 1. So when I divide, okay, so notice how the degree on the top is 2 and the degree on the denominator is 1. This is, therefore, this dot right here represents therefore, this is an improper. An improper function. Okay, it's an improper rational function. Because it is an improper, we are going to end up with an oblique asymptote, which is a y equals. And I'm going to box it up. I'm going to do the work underneath it and then write my answer in that box. Alright, well, r of x equals 5x squared divided by x plus 3. So this line right here is simply just that, a division line. So I'm going to do long division with a pencil just in case I make a mistake. So I'm going to do, where should I do it right here? Okay. So in here I would have 5x squared, but because I am missing an x, I'm going to fill in my placeholder, and I'm missing a constant, so I'm going to fill that in as well. Over here I'm going to write x plus 3. Okay, I'm not missing anything. This is x to the first power, and this is a constant. So 5x squared divided by x is going to be 5. And then x squared divided by x is going to be x. So 5x times x is a positive 5x, but remember we have to subtract, so switch your sign. 5x times positive 3 is a positive 15x, but I need to switch my sign to negative 15x. Okay, so from here, those two will cancel. I now have a negative 15x and bring down my 0. Negative 15 divided by x is a negative 15. Multiply it back. Negative 15 times x is a negative 15. Switch my sign to a positive 15. And then multiply, that's x. Negative 15 times 3 is negative 45. switch the sign to positive 45. So currently I have these two being canceling each other out. A 0 plus 45 is a 45. This is your remainder. Okay. So my answer, okay, the answer, which is what we call a quotient, is the answer to the division problem, is going to be 5x minus 15, and then we have a remainder, which is 45, and we put it over our divisor, which is x plus 3. Okay. So this is the quotient, okay, which is the answer to our division problem. But remember, in class, we are always going to assume as x approaches a really large number, okay? It can be a negative infinity or a positive infinity. It doesn't really matter which one. So what happens if x approaches a super big, like 1,000, okay? So 45 divided by 1,003. That's a really large number, okay, for you to divide. So 45 divided by a large number. That's so small that it's going to get closer and closer to 0. Because it gets closer to 0, we are going to ignore the remainder because it's not as significant. Okay? So anytime, and you can spell this out, okay, spell it out so that way you have something to remember. Anytime you are looking for the oblique asymptote, you can ignore the remainder. Okay, so spell it out. Looking for the oblique asymptote, you may ignore the remainder. So in my oblique asymptote, I would only write 5x minus 15. Okay, and again, I can ignore the remainder because if x approaches a super ginormous number, this is getting closer and closer to 0. So I don't need to worry about it. Okay? So that's our example A. Now let me try to make room for example B. Okay, example B. First, we are going to look for the vertical asymptote. So VA. And then box it up. Okay. So however you find the domain, but that's exactly the same way we would find the VA. We are going to take the denominator. Okay, we're going to set it equal to 0. From here, we can factor it out. I'm going to give you about 10 seconds to see if you can factor that out on your own. Okay, hopefully you are writing x plus 4 and x plus 1. You can write x plus 1 on the front and x plus 4 on the back. It's not important. So take each factor and set it equal to 0. So my first VA is x equals to negative 4. My second VA is x equals, to negative 1. So look, I have two VAs, okay? There is no limit to how many VA we can have. We can have as many as the function gives us. So the VAs are x equals negative 4, and yes, you are required to write x equals. Okay, it's a line. Asymptotes are lines. So x equals to negative 1 and x equals to negative 4. Now, it doesn't ask for domain in here, but remember, the domain is completely related. Okay, the domain is x can never be negative 4 or negative 1. So notice how that's related to your VA. Okay. Now, with that said, let's try to see what the degree on the numerator is. Since it is already in descending order, let's just write the degree. The degree on the numerator is 1. The degree on the denominator is 2. Okay, so far so good. Therefore, this is not an improper. Okay, we're going to have an HA. So we're going to write HA, I'll box that up. This is where it's going to go. And to find your HA is quite easy. Okay, to find your HA, again, you're going to need a y equals. Okay, asymptotes are lines. So horizontal asymptote, I'm out of lead. So let's give me a second to find another pencil. Okay, so horizontal asymptotes are line, vertical asymptotes are line, oblique asymptotes, they're all lines, okay? So make sure you have a y equals with oblique or horizontal and x for VA. So we are going to take an n behavior on the top, n behavior divided by the n behavior on the bottom, n behavior. That looks funny. Okay, so all you are doing to find your horizontal asymptote, it's really the n behavior divided by another n behavior. So the n behavior on the top, and this is all really back to the notion of limits, right? As x approaches a super large number, -1 is really obsolete. It's not obsolete, but it's not as significant. And if you have a -1,000,000 and I square that, it's really, these right here is really not as significant. Okay, so the n behavior is really what we are looking at. So y equals, the n behavior on the numerator is x divided by the n behavior on the denominator is x squared. Of course we would reduce in math, right? So this is going to give me 1 over x. Okay, and again, we will always assume x approaches really large really large numbers, negative or positive. So either way, this is approaching 0. So 1 divided by 1,000,000 is very close to 0. 1 divided by -1,000,000, it's also very close to 0. So my horizontal asymptote is really y equals, yes, you are required to write y equals 0 for that piece. Okay? So remember, the degree on the top is smaller and the degree on the bottom is larger, so therefore it's not an improper. Okay, right? And we find HA, take the n behavior on the top, divide by the n behavior on the bottom, always reduce, and assume x approaches a really large number to see what y it's going to be. Okay, last part of example 1.